And well, it still worked.
Yeah, so this right here really shows how well it works.
Yeah.
And then over here is an example of a data where the data itself is in 2D, and after the second layer, third layer, fourth layer, you can physically see that the data is being of each cluster is being pushed as far away from each other as possible. And you can and once you reach that point, it's really easy to tell them apart.
Mhm. Yeah, absolutely. Yeah, it's really interesting. Do
Yeah.
you think that like kernel methods could be translated into other applications beyond like classification? Like maybe more like downstream ML tasks?
So kernel methods could be used for classification, regression. It currently is being used for um, modeling. So if you have some data,
Hmm.
you can identify the probability distribution of the data.
Yeah.
I don't know if that makes sense to you.
Oh yeah.
Yes?
I think yeah.
Okay. Yeah. So once you know the probability distribution of the data, you will be able to say what the likelihood of certain events.
Yeah. Yeah. Makes
And you can use it for like detection. So let's say you have hackers and you can detect anomaly. You can
Mhm.
use that. So actually you can use kernels for a lot of stuff.
Yeah. Very interesting field. More on your research. So earlier you mentioned you had a project on I believe it was like premature. I think
Birth.
it's yeah, premature birth. Yeah.
Yeah.
Uh, so do you have you have an interest in I guess like the intersection of biology and ML as well?
I do that. I have a very strong interest. Right now, I'm actually working on a project.
Mhm.
The premature birth was several years ago, but right now I'm working on a project of I understanding the neurological development of babies.
Oh wow. Hmm.
So babies obviously they can't talk.
Yeah.
So how do you how do you decide or measure how well they are like developing
Yeah.
neurologically, right?
Mhm.
So that's basically like currently the project I'm interested in working on right now.
It's cool. Uh, can you potentially like talk a little bit more about that project and I guess how you guys are measuring like neurological development?
The thing is the paper is not published yet, so and I'm not the lead, so I don't know how much I should give
Oh,
away.
that's absolutely
Yeah,
fine. Cool.
that's my concern. If it's already published, then it's fine. But
Yeah.
yeah, it's not my it's because I'm just analyst in the project, like
Mhm.
the psychology department, they are the main people. I don't know how much they would want me to tell the
Yeah,
public. Yeah.
absolutely.
But it would be cool if you can measure whether a baby is developing um like properly. Like
Mhm.
that's
Yeah.
something I think people care about.
Mhm. Do you have any like other past projects that with like relating to like the intersection of bio and ML that you could potentially talk about?
No, but I am currently like right now I'm teaching a lot. So my focus is mostly in teaching, but once I have a little bit more time, I would really like to work on probably like more biological projects relating to human aging.
Mhm. Yeah, absolutely.
Like I like, for example, recently there's a lot of effort to measure a person's age, biological age. So like they will take your blood samples and measure essentially how healthy you are. And there's a big intersection between like health biomarkers and machine learning. So I think that will be the direction I will go in the future when I have more time. But as of now, I'm focusing on teaching.
Yeah, Okay. Yeah. absolutely. Kind of a broader question. What motivated you to explore machine learning, signal processing, and kernel methods as a whole?
So I was in I was in signal processing. So when I was doing signal processing, it was like one of the hottest subjects at the time. But then um But then I realized that I really realized that the future is going to be machine learning.
Mhm.
And that's when I decided to change fields.
Yeah.
And I think I'm right about that.
Yeah. Yeah.
Sure.
Absolutely.
The machine learning is going to really take over.
Mhm.
So I just see so many possibilities you can do. And the most amazing thing is like, you know, so a lot of people they pick a profession. You
Yeah.
pick a profession like, I don't know, plumbing. You're a plumber. And then you kind of just do plumbing, right? It's not like you're gonna suddenly do plumbing and then go do psychology.
Yeah.
Or
Yeah.
if you do psychology, you're not gonna go do plumbing. The interesting thing with machine learning is machine learning, it's needed in every single field.
Yeah.
Mhm.
So
Absolutely.
like, so you can do machine learning, you can do hardcore machine learning and just be stuck with the theoretical stuff all day, or you can explore other interests you have. And one day you could be working on like psychology, human development. Like another day you can be working on biology or gaming. I mean, like it depends on your interest. So I really feel like it's something that just every single field needs. That that's a real advantage, and that's what really was attractive to me.
Mhm. No, that makes absolute sense.
Yep. So how do you envision building like interdisciplinary like collaborations with ML and other different fields?
So I am currently working with other fields. So what I do is basically I got to know a bunch of colleagues, and then we talk about potential projects together,
Yeah.
and that has led to some stuff that are in. Oh wait, there was this one research I forgot. Do you want me to talk about?
Yeah,
Oh, sure. Yeah.
absolutely.
That one is being published, so that one I can talk about. So there's this thing called well, you guys know cells, from biology.
Yeah.
So there's this thing called the Raman spectroscopy, and
Mhm.
Raman spectroscopy is essentially a technique where you shoot lights on an object,
Yeah.
and depending on the light that reflects back, different material actually reflects different frequencies.
Yeah.
So you can kind of picture it's a way of IDing an object.
Yeah, that makes
Yeah.
sense. Yeah.
So imagine if we have different cells. Now you can manually look at every single cell and then study them and then identify the cell type.
Hmm.
Yeah.
Or you can use Raman spectroscopy and then collect the data on the frequencies it reflects.
Yeah.
Yeah.
So the technique we developed in this particular project is, can we find an ML algorithm, machine learning algorithm, that takes the reflective frequency and automatically identify the cell type.
Mhm.
Hmm. That seems very
And
intuitive.
yeah, and once we have that machine, then you don't have to do it manually. You can have a put the cell in, and they'll just shoot a bunch of lasers, and then before you know it, you got the identity of 1,000 cells.
Yeah. Very
Hmm.
useful.
Yes, yes. So that was like another project that we did using machine learning.
It's awesome. Yeah.
Do you know if it's currently being implemented anywhere or if it's entered into the market for
Are you talking about this algorithm I developed?
yeah.
Actually, we are writing the patent and we're
Oh,
building the machine currently. So
yeah.
yeah, it's going to be used, I hope.
Yeah. No, I think it's extremely beneficial for the medical industry and especially given how much fields rely on knowing about the cells that it could be very
Yeah, what's cool is like we don't have to just stick with cells. Like we can actually use it for anything. But
Mhm.
we haven't got to that point yet.
Yeah.
So how many cells were you able to like how many classes were you able to differentiate between for the cells?
But the starting point, I believe, was 32. But the 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 goal is to keep expanding the library. And as we
Yeah.
get more library, we'll be able to train more and more.
Mhm. Absolutely.
And out of curiosity, what kind of architecture did you use for classification?
But this one, so we use this thing called Fourier transform.
Yeah.
Mhm.
And then once you have the frequencies of the Fourier transform, we did this thing called the LDA.
Okay. Yeah.
Um, this called linear discriminant analysis. And then we use like an SVM type of algorithm.
All right. Yeah.
So I mean, you I guess you would need to know what all these like acronyms mean, but that's yeah, that's basically how it works.
Yeah.
So
Yeah, we have like a couple more questions, but I guess like the next one for students who are aspiring to make an impact in ML and related fields, do you have any advice that you would give them?
yeah, yeah. So right now, because ML is so hot,
Yeah.
um, a lot of people are trying to get into it,
Yeah.
and therefore, like universities and place different institutions are trying to meet that demand.
Yeah.
I've noticed I've noticed a split
Mhm.
where where some of the some of the teaching they basically teach you how to code to solve various problems.
Yeah.
So that's one way to do it, and another way is to basically teach you the math behind it.
Yeah.
Mhm.
I don't know if you can see what the difference I'm trying to refer to. One is basically cut and paste. Is like you meet this problem, this is the code you want to use. You meet that problem, that's the code you want to use, which
Uh-huh.
is useful because as long as you can remember the situation and how to run some code, you will
Yeah.
be able to solve the problem.
Mhm.
Yeah.
However, if you were to do that, you don't really know what's going on.
True.
Yeah.
And and if if somebody like a new student wants to get into machine learning, wants to get into ML, I recommend the students to be cognizant of what they actually want to get out of it. Do they
Mhm.
just want to, memorize a bunch of code and cut and paste them at the right time?
Yeah.
Or do they actually want to know what's going on?
Yeah.
And it's kind of a philosophical divide because for simple tasks, for simple tasks, you could just cut and paste and you're going to get the result. And ultimately, maybe that's what people care about, the results.
Yeah.
However, then if something goes wrong, then you
Mhm.
don't really know what's going on.
Yeah.
So I really question that methodology of just teaching the students like how to cut and paste various code.
Yeah.
And my recommendation for the students is basically you need to have thought about that and make sure the places you're going to, classes you're going to take, teaches in in accordance of what you want.
Yeah.
Yeah.
Like, do you want to actually know what's going on, or do you want to know just enough to get some stuff done?
Yeah. Because those are two very different curriculums and could have two very different impacts as well on the field,
Yeah,
especially.
yeah, they're very very different. Like if you could go relatively far, just cut and paste code. You can do quite a bit, but I personally feel like something's missing if you
Yeah.
if you if you're just cut and pasting stuff.
Yeah.
So yeah,
Yeah. On that note, actually, what are your thoughts on like AI programming assistants and I guess like how much more advanced like language models are becoming with helping students develop their code?
I actually think they're really great. Um, I think they are really going to help students with productivity. And I
Mhm.
actually think it's going to be the future. I um I think in the future it's not going to be just like you don't need to memorize all the syntax. You don't need to know. In fact, you probably don't even need to know a lot of code. I
Yeah.
think in the future when like large language models gets really advanced, you will become like a conversation.
Yeah.
Like you may not even need to type. Maybe you can just talk to a machine and say, make me a website that's kind of like this.
Yeah.
Mm.
And then after they pop up a website for you, you can say, change the banner into this.
Yeah.
Um, change the theme to make it a little sadder.
Mhm.
Or make it happier sounding intro.
Yeah.
You can essentially just talk to it, and you'll probably be able to do a programming in the future. So um, in terms of like what you're saying, like this assistance, I actually think that's only in the beginning of the evolution. I think in the future you might not even need an assistant. I mean, you might not need to type with an assistant. You could just talk to them,
Wow.
Yeah.
Definitely.
and at that point, um, yeah, I at that point, like I would question whether it's worth learning how to program a lot.
Yeah.
It's an interesting thing to think about.
Yeah, and this is why I'm saying like if you if you all you know is to cut and paste code,
Yeah.
and now ChatGPT can do 1,000 times better job than most people in cut and pasting code.
Yeah.
Yeah.
So I yeah, if people going to do that, I believe they're what they do would be easily replaceable. But if you really understand the math, that's a different story.
Mhm. Absolutely.
All right. On like a lighter way to end off the episode, you just want to talk about any like fun facts or like non-academic interests about yourself?
Hmm. I mean, I guess I have lots of interests. Um, so every single semester, I give extra credits to my students. Any student who can beat me at a 3-point contest.
Basketball?
Yeah, yeah.
That's so cool.
So I give it's not a lot. It's like a rounding point. If they miss the next grade by like half a point.
Yeah.
Yeah.
That's very cool.
Nobody's really beating me handily though.
I might be able to give you a run for your money there.
You think so, huh?
He absolutely cannot. All right.
Yeah.
Thank you so much for your time today. We greatly appreciate it.
Okay, no problem. I hope this will be helpful.
It absolutely is.
Yep.
Actually, do you want me to send you the link?
Yeah, that'd be
Oh,
great.
sure. That'd be great. Yeah.
Okay. All right then. All
Thank you
right.
so much
Yep.
for your
Talk
time.
to you later. Yep. Bye.
Have a nice rest of your day. Bye.